Title of the report to be published:
Dynamics of water-based ternary-hybrid nanofluid on a horizontal surface, the case of mathematical analysis of Brownian motion and thermo-migration of different nanoparticles.
Details of the journal to publish the report.
Publisher of the journal, Elsevier BV. Journal to publish the report, Surfaces and Interfaces. 2020 Journal Impact Factor, Web of Science. 4.837 Quartile 1. Top readership of published reports by the journal, China, India, and United States.
This preamble presents ternary-hybrid nanofluid.
Recent discoveries about the potential and uses of nanofluids have yielded several facts about the nature of nanoparticles and their ability to affect the pace of heat transmission across the host fluid. In agreement with the fact mentioned by Animasaun and others, 2022, a well-known strategy for changing the thermal conductivity of fluids is the inclusion of either metal or metal oxide nanoparticles in the base fluid. Ekisela, 2020, confirmed that the most useful nanoparticles are metals because of their higher thermal conductivity coefficient than that of typical fluids. Recently, further exploration of nanofluid has led to the dispersing of 3 kinds of nanoparticles in a base fluid to form a stable ternary-hybrid nanofluid, see Sunder and others, 2021, and Thanarel-Nakib and others, 2021. Mooney, 1951, demonstrates that the viscosity concentration model of a fluid material varies with particle size/shape. However, little or nothing is known about the dynamics of water extensively mixed with 3 distinct types of nano-sized particles inside the thin layer of fluid where viscosity effects are substantial, with a focus on the fluctuation of friction, heat, and mass transfer rates between the final layer of fluid. Why water-based nanofluid? The inherent issue of heat transmission is perhaps the most well-known concern in heat exchangers. Water is a universal solvent readily accessible and not expensive. Consequently, water is often used in the industry for the processing of nanofluids because of its poor thermal conductivity property that calls for improvement if to be used as a heat exchanger by suspension of nanoparticles. See Hassan and others, 2015. Do you know that random motion and thermo-migration of nano-sized particles are 2 well-known characteristics that can affect the transportation of ternary-hybrid nanofluids together with the heat and mass transfer?
Next is to present the research questions of the study.
Sequel to the study mentioned above, scientific answers are needed to the following research questions.
During the dynamics of a water-based ternary-hybrid nanofluid, how does increasing the volume of nano-sized particles impact the friction between the last layer of fluid and the surface? In the case of different spherical, but fixed cylindrical and platelet nanoparticles, how does the haphazard motion of nanoparticles influences the motion of ternary-hybrid nanofluid made up of water? What is the effect of thermo-migration of nanoparticles on water-based ternary-hybrid nanofluid when cylindrical and platelet nanoparticles are fixed, but at different kinds of spherical nanoparticles? How do variations in erratic motion and thermal migration of spherical nanoparticles impact mass and heat transfer when the nano-sized particles are extremely dense, silver nanoparticles, and less dense, aluminum oxide nanoparticles?
Acknowledgements.
Special thanks to all the editors and reviewers of Surfaces and Interfaces. We share Ter appreciates the contribution of the authors to the body of knowledge.
We share
Theoretical and empirical reviews.
It is all about learning research facts and sharing with others.